in today, but on the plus side, we won't have as many definitions next week. Kind of getting through that really wordy part. So we have this back page, and we're pretty much going to do all of these terms today, and then that's it for the terms, and we'll just be doing stuff after that. So we keep talking about, we've talked about like a designed experiment before, so we've used the term experiment. It's just a controlled study that is conducted to determine the effect of varying one or more explanatory variables. Those could also be called factors. That's the thing we manipulate. And you're measuring a response. In an experiment, today we're going to kind of be looking at experiments and identifying different things within them. So the experimental subject or unit is the person or object which you are applying your treatment. So if I wanted to see if you like last year's milk or this year's milk at school better, and I had each of you taste both of them and tell me your favorite, each of you would be an experimental unit. You're each going through that treatment. In some scenarios, we might have a control group. So that would be our baseline that we use to compare the others to. So maybe I wanted to see if adding flavoring makes the milk better. So our control group would be just your basic white milk. And then your different treatments could be strawberry milk or chocolate milk, the flavors that we add. A lot of times in experiments you'll hear about a placebo. You guys know what that is? A lot of times in medical trials, if they're trying to test if a new medication works or not, they might have a control group that they give a placebo to. So a placebo might just be like a sugar tablet. It really has no bearing, but they want to make sure that any effect is from the medication, not from people just thinking they have something that's making them better. So a placebo is something that looks just like the actual drug, but has no effect. Examples. So there are sometimes experiments where somebody doesn't know what treatment they're getting, like in the placebo example. Okay, I give two people pills. One of them is supposed to, get rid of acne, and the other one is a placebo. And so I give two people these pills. Would I want to tell them, you're just getting a sugar pill, you're not really getting the real drug? No. But would I need to know which one they're getting? Probably. So they don't know which one they're getting, but I, as the person conducting the experiment, do. Because at the end, I have to be able to see, did the pill work or not. So if the researcher knows, but the subject doesn't, that would be a single blind experiment. One person doesn't know what treatment they're getting. A double blind might be a situation where neither one knows. So the researcher doesn't know, and the subject doesn't know. in that kind of situation, you would typically have to have a third party that did know what treatment was being used. So maybe for whatever reason, the medication I'm giving, I thought that I might give it away. That I couldn't be trusted not to tell or treat the subject differently if I knew they were getting the real drug. So there might be a third party that knew who was getting what when I didn't and the subject didn't. So the English department of a community college is considering adopting an online version of the freshman English course. To compare the new online course to the traditional course, a faculty member randomly splits a section of her course. Half of the students receive the traditional and the other half get online. At the end of the semester, both groups will be given a test to determine who performed better. So, who are the experimental units in this? Students in the class. Hello. Sure. Oh yeah, she can come in. Thanks. Bye. Okay. What would be the population here? All the students. Who do I want this to apply to? We're really looking at the freshmen at this college. Okay, if I ask for the treatments, what would those be? Online and traditional. Okay. So that's kind of like the treatment. It can be called the factor. It can be called the explanatory variable. A lot of different words for that one. What is the response that we're looking at? Who does better? So the test score at the end. Okay. Why couldn't I use blinding in this situation? The teacher has to know, are you going to know if you are taking an online or an in-person class? Yeah. The teacher is going to know, the student is going to know, there's no hiding that from anyone. So everyone knows what class they're in. Is that clear with everybody? So, in general, if we are going to design an experiment, there are certain things that we have to do. The first one, we always have to identify our problem to be solved. We have to know what factors are going to affect the response. Did I not put this on your slides? Okay. You don't really have to write this down. I'm not going to ask you this process. This is just kind of the things that we're talking about. So we have to know the factors, the things that are going to impact the response, because we have to be able to control for them. And we have to know how many experimental units or subjects we're going to have. We have to figure out, are we controlling or randomizing each factor? Okay, was that it? Yeah. Okay. And then at the end, of course, we have to conduct the experiment and draw some conclusion about it. So those are really the things that we are going to be working on this semester. Kind of how to set up an experiment, which is our focus right now. Then we'll talk about, how many people do we need? How do I control these things? How do I interpret the answer? A couple other ways of experiment. So we talked about single and double blind. Completely randomized. So there is no rhyme or reason. Everybody is randomly assigned a group. So I am deciding if you're taking the online or traditional class. So I have you walk in my classroom and roll a dice. And if you get an even, you're taking it online. If you get an odd, you're taking it in person. Totally random. I didn't even make sure it was the same number of people in each group. I didn't control anything. We could have a matched pairs design. So matched pairs, we are pairing up our experimental units. They need to be somehow related. So maybe I am going to give a survey to a husband and a wife and see what they think. Or maybe I'm going to see if I'm effective at teaching this class. So I'm going to give you a pre-test, and then at the end I give you a post-test. You have your score from the beginning and your score from the end. So those would be matched pairs data. They are related to one another. Two other experiments that we will see. Blocking. So we group together similar experimental units and then randomly assigning them to a treatment. So we group together ones that are similar. That's blocking. An engineer wants to know whether the level of octane in gasoline affects the gas mileage of an automobile. Give me some ways I could design an experiment for this. Talk through it. So, what are we trying to figure out? Okay. How could I do this? Okay, why does it have to be the same car? Right. If I just had each of you take your cars and I said, all right, you three get this, you three get this, you guys get that, would that be an accurate comparison? No. Different cars get different gas mileage anyway. What if we do the same make and model but different years? Would that make a difference? Yes. So because we know that they're always trying to improve fuel economy. Right? So if you're driving a car that was made in 1990, the same car made today will probably have different gas mileage. So we would need to pick all vehicles to be the same. We're trying to control, what am I trying to control there? Yeah, controlling the level of octane, and to make sure that it's really the level of octane that's showing any differences at the end. I'm trying to control for any lurking variables, anything like that. So we would need the same make, model, year. What about condition of the car? What? Yeah, Yeah, if somebody has, if it's one that has a salvage title on it, could that be different than another car? Yeah. So we need really the same make, model, year, and condition. And what else? Tires. Yeah, exactly. Condition. Tires make a difference. What else might make a difference? The roads. They need to be driving the same roads. Speed. We need to be driving the same speed. Same distance. You notice we're trying to make everything else the same. So we know at the end what caused any differences we saw. So we need same make, model, year, condition, road. Yes. I don't want to drive one on a beautiful sunny day and one when we have torrential downpours. That wouldn't be the same. What about driver? Would that make a difference? Like, when I drive, I'm one of those people that I know, okay, I'm going in town, speed limit's going to drop, and so I just let off the gas and kind of coast in. My husband is one of those people that he keeps the gas down right until he gets his sign, then slams on the brakes. It's a very different driving style. Does that impact? You're absolutely. So we really would want the same driver for both of them. So essentially, we are trying to keep everything the same except the level of octane. So all those things are the same. We will vary the level of octane. And then compare the mileage. So I might say, okay, we're going to take this car and I'm going to fill it full with this level of octane. I'm going to drive around this track until the car is empty and see how many miles I drove. Then I'm going to put the next level in it and drive around until it's empty and see. Would that be effective? Yes, but when you're designing an experiment, you have to control everything that might have an impact on the outcome, except the one thing we want to vary. What do we call the thing we're varying? The explanatory variable or the factor. What's my response variable I'm looking at here? Mileage. The mileage. The thing we're measuring is our mileage. Good. Okay, let's look at this example. Xylitol has proven effective in preventing cavities when included in food or gum. So we have 75 children given milk with and without xylitol. And they were asked to evaluate the taste of each. They measured the child's rating of the two types of milk. So what is the response here? Okay, so the factors in the study, the explanatory variables, the things we're manipulating, what would be our factors? Yeah. Whether they had the milk with or without the xylitol. Is that controlled? Yes, that's the one being, or is that controlled or manipulated? Is that the one I'm changing? Yeah, I'm going to manipulate that. So I know if you're getting the milk with or without. All right, so what they're having is I'm going to give Carson both types of milk. He's going to drink each and rate them. Okay, so I'm controlling what he's getting, the two types of milk. I manipulate whether it has the xylitol or not. What other factors might there be? Is there anything else that could have an impact? What? Hygiene. Okay, so we would want to make sure like the milk they were both cold, clean cups, those kinds of things. Do you think it would matter if every child I gave the regular milk first and then the one with xylitol after? Maybe, maybe not. If you're really, really hot and thirsty and I give you a cold drink, does that taste pretty good? Does the second drink taste as good? Not usually. So would I need to mix up the order that I give them? Probably. So we need to deal with order. Okay, that's not really the one we're going to manipulate. That's one we need to control. We need to know that I am mixing that up. Because if I give everybody the xylitol second, then that might change their outcome. What if I give Izzy the cup of milk with xylitol and she goes to drink it and I go, like, would that make a difference on how she reacts? Yeah, if I'm making a face like, oh, that's going to be awful, she's probably going to think it's awful. So the researcher, or if I give her the xylitol one, this one's really good, we're really going to like this. Is she going to be more likely to rate that one higher? Yeah, so the researcher has to control their behavior and make sure it's the same for both cups of milk. So that needs to be something we control. Okay, treatments. So the treatments, that's just kind of another way of saying the factors, the experimental units. So what am I looking at? It's the milk with or without. So how many treatments are there? 2. Okay, what kind of experimental design is this? It's single blind. I know which one they got. Do they? No. Depending on how the data is looked at, it could potentially be a matched pairs as well. If I were looking at, okay, here's how you rated this one, here's how you rated this one, I'm going to compare your rating of the two. So just kind of depending on how I looked at that data. Who are the units?
Kids.
Yep, the 75 kids that we looked at. We already just talked about this one, why it would be a good idea to randomly assign. So basically we're just trying to remove that working variable. Okay. Could it be a good idea to do a double blind in this one? Yeah. I mean, if my face is going to give it away, or I'm doing this and I really want to prove that milk with xylitol tastes better and they're going to like it, I might be biased. So it might be better to do a double blind. So someone else is pouring the milk and I'm just handing it to them. All right.
Would you have to make it the same color?
Yes, you would have to make sure it's same color. You'd want the cups to be the same, all those things. You know, some people, like my daughter really likes drinking milk out of straw. So if I gave her one cup with straw and one cup without, she's going to pick the one with the straw, regardless of what's in it. So everything else has to be the same.